Hello folks, this is 2022 May-June paper 2-1 and the question number is 3. This question is concerned with the chapter work, energy and power. As you can see, 3A1, the first thing is to define power. So power is the rate of work done or the rate of doing work. As simple as that. Now, a force F takes a time t to move an object through a displacement x. So displacement is x, the force is F, and the time is t. At constant velocity v in the direction of the force, the work done by the force is W work. Use the definition of power to show that the power P transferred by the force is given by P equal to Fv. It's an obvious equation, so we have to prove it. So simply put, power is equal to work by time, and the work is equal to F S cos theta by t. But here what it says is constant v in the direction of the force, the angle theta should be 0, so it is Fs by t only. So it is F into S by t, and this S by t at constant velocity v should be equal to F into v. So it is valid because it is stated here that the velocity is constant. So that's why valid. So this is Fv. So proven. Now number B. A block is pulled up a slope by a wire attached to a motor as shown in figure 3.1. The useful power output of the motor is 56 watts. So this is power out like this, 56 watt. The block has a weight of 430 Newton W and travels with constant velocity along the, so this thing is to be highlighted, constant velocity to be remember, along the slope at an angle of 11 degrees. So alpha is equal to 11 degree to the horizontal. Assume that there are no resistive forces, so things are simple. Opposing the motion of the block, calculate the tension T in the wire. So what happens here is the tension T in the wire is T. So somewhere here the tension T acts in this direction is T, and the component of the weight exerts a force here like this. This is, let us name it as Fp. So I have so this T minus Fp is equal to mass into acceleration. Since the velocity is constant, this A is 0, so T minus Fp is resultant force, that's equal to ma. So T minus Fp is W. So this is W here, W. This is 11 degree alpha. So the force here should be equal to, Fp should be equal to W sine of alpha is equal to 0, which means T equal to W sine of alpha. So T is equal to W is 430 sine of 11 degrees. So when I do the calculations, it will become, so 430 into sine 11 will be equal to 82.048 newtons. So equivalent to, it is 82 newtons. So it is 82 newtons. So this is the tension in the wire. Now next is calculate the speed of the block. So the velocity is uniform. So to find the speed of the block requires this equation, which we had proven previously. That is this thing. So it is Fv power. So power equal to Fb. Power is equal to F into V. So this gives us V is equal to power by F. That's equal to, so power is equal to, the power is equal to 56 watts. So this is power here, and force is equal to this much tension force here. So is power equal to 56, the force is equal to 82 Newton. So that becomes equal to, so it is 56 divided 82 is equal to 0.0685. So if I use 2 SF only, it becomes 0.68 meter per second. Now the rate of increase of gravitational potential energy of the block is equal to the useful power output of the motor. One of the reasons for this is that there is no work done against resistive forces. So by considering the motion of the block, state another reason for this. So actually what happens is the power thing is equal to energy total by time. So this should be equal to PE plus KE by time. And one thing that we have to remember is that K equal to 0. The change of K here is equal to 0. So that's why it is simply, let us say it is a change of energy, change of this thing. So only the change of potential energy remains here by time, because it's because change of kinetic energy equal to 0. It is because V equal to constant. So this is another reason for this. Now number 4. The motor has an efficiency of this much, so this is equal to efficiency, eta symbol here. Calculate the time taken for input energy. So this is E input, often called as Q1 also, equal to 1200 joules to be supplied to the motor. So what we have is efficiency is equal to power out by power in. This gives me power in is equal to power out by efficiency. So power in is equal to E in by time is equal to power out by efficiency, which gives me time is equal to E in into efficiency by power out. So this gives me T is equal to energy input is 1200, so it is 1200 here, 1200 into efficiency is 80%, which is 0.80. I changed that into decimal, and our power out is given as 56, so it is 56 here. So this will be 1200 into 0.8 divided 56 equal to, so it becomes 17.14 seconds. So nearby equal to 17 seconds to SF. So it is 17 seconds. So this is the answer to this question.